Hey everyone, this video is the introduction for exercise 5.2. So here we'll learn some of the differentiation formula and we'll start doing the problems. So please note down. So we'll start with the first one, which is derivative of, which is written as d by dx of x raised to n is given by n into x raised to n minus 1. Okay. Number 2, d by dx of x. What will be d by dx of x then? It will be 1. How do you get it? This is x raised to 1. That will be 1 into x raised to 1 minus 1, or 1 into x raised to 0. Any number raised to 0 is 1. So the answer is 1. So this you get from here. Next is d by dx of, that is derivative of a constant. It is not changing. So even if you find a tangent, it will be 0. The tangent of a constant. Derivative of a constant is 0. So this is the first 3 sets. Next we'll go to the trigonometric functions. Number 4, d by dx of sin x is cos x. D by dx of cos x is minus sin x. Okay. See, whenever you are, when you are finding the derivative of something that starts with c, the answer will always be in negative. Just like a thumb rule, you can keep that in mind. Okay. So d by dx of cos x is minus sin x. Sin cos tan. Okay. D by dx of tan x equal to sec square x. Okay. So please note down till this. We'll go to next one also. D by dx of tan x, then we'll write cot x. Cot x is equal to, cot x, this is starting with c, so this will be negative minus cosec square x. The next is d by dx of, tan x is over, we'll write sec x. Sec x equal to sec x tan x. Alright. The ninth one is d by dx of cosec x. Cosec x, see, it's starting with c, the letter is c, here also c, it will be negative, this will also be negative, minus cosec x cot x. Okay, so you have all the formulas here. So the thumb rule is that whenever you are finding the derivative of something that starts with c, this negative sign is here, so you have to keep that in mind, so that whenever you derive, you find the derivative of cos x, cot x and cosec square x, don't forget to put this negative sign, otherwise your answer will be wrong. Now these are the trigonometric formulas, the derivative of trigonometric functions. Now we have to learn a little bit of the algebra of derivatives, okay, and some rules as well. So let's go to that. Please note things down. Okay, so now let's discuss the algebra of derivatives. Number 1, let's say we are finding the derivative of d by dx of k into some function. Okay, some function is multiplied with some constant k. Then it will be, k comes outside, then you are finding the derivative of the function. That is d by dx of f of x. Okay, so let's take an example. So what do I take? Let's say you're finding d by dx of 2x square. Okay, so how will the derivative be? It will be 2 comes outside, 2 is a constant. Okay, just like k into f of x, 2 comes outside. Then you are finding d by dx of x square. Okay, we will find the answers of x square in the exercise. I'm not explaining it here. This is to make you understand the algebra of derivatives. Okay, this is the first one. The next is d by dx of, let's say, sum or difference of two functions, f of x plus g of x. Then distributive law, you can simply take it inside, and that will be d by dx of f of x plus or minus d by dx of g of x. If you would like to take an example, let's say d by dx of x square plus sin x will be plus or minus, let's say, it will be d by dx of x square first, then plus or minus d by dx of sin x. Okay, the first one, second one. The third one is called multiplication or the product rule. The product rule. That is, let's say you're finding the derivative of multiplication of two functions, that is f of x into g of x. In that case, what do we do? So here is a rule that you have to follow when there's a case like this where you're multiplying two functions. It will be first function into derivative of, this is equal to first function into derivative of second plus second function into derivative of first. Okay, in some textbooks they write it as u v, and where u dash and v dash will stand for the derivative, then this will look like u v dash plus v u dash. Okay, if this is difficult for you to remember, it is just like remembering first into derivative second plus second into derivative of first. Okay, so we have just covered constant into a function, sum and difference of a function, then the product rule. Next we'll go to the quotient rule. So please take a note. Next we'll discuss the quotient rule. Quotient rule, that is what to do when you have to find the derivative of function that is in this form, that is f of x divided by g of x. Okay, so this is clear to you. So what to do when you are dealing with functions like this, I'll tell you. This will be equal to denominator into d by dx of numerator. Okay, this dash stands for derivative, minus numerator into d by dx of denominator, the whole divided by denominator square. Okay, just like before, if you would like to name this as u and v, then this would look like u v dash minus v u dash divided by v square. Or for simple way of remembering, I usually put this as n and this as d, and this will be dn minus nd divided by denominator square. This nd is similar to the word and in English. Okay, nd. So dn minus nd, it sounds like and, nd, and n, this is the end, no? end, this is the end. Okay, you can think of it like that way also. This is the ending portion. This will be dn minus nd divided by denominator square, where the second letter is the derivative. Alright? Okay, so the last rule you have to learn is called the chain rule. So here you have to understand certain things. Let's say f of x square is a combination of two functions. Okay, this is let's say g of x is cos x and h of x equal to x square. Okay, so this is, instead of x, if I put x square, I get cos x square. So I can say this is g of h of x equal to cos x square. Okay, we apply chain rule whenever there is a combination of two functions. There is one function within another function. So how to do such questions? Let's see. We don't know how to find the derivative of cos x square, but I know how to find the derivative of cos x, right? Let's say if cos x was given, then d by dx of cos x will be minus sin x. Okay, this I already know, this I have learned, but cos x square I don't know. I don't know how to do cos x square. So let's say I'm going to put this as some variable. What do? I'll put it as a. Okay, let's say f of x is equal to cos a. Okay, so a is a function of x. A is another function of x. I don't know what it's given as x square. I'm just taking it as x. Taken it as a. Okay, now tell me, can I find f dash x? Of course I can. F dash x will be d by dx of cos a, which is minus sin a. But it is not over. Okay, that's where the chain rule comes. When something happens, it sets a chain that you find the derivative of first function, then you go to the derivative of next function, and you will keep on checking if there are more functions coming up. So here there is only one function coming up. So this will be sin a into d by dx of a as well. Okay, like I told you, this here I applied derivative to this function as a whole. After doing the first derivative, I understood that there is another function within this function. So I will find the derivative of that also. Okay, so let's see, here it is finished. So when I substitute things back, I'll get minus sine A. Instead of A, what do I get? I have to put back x square into again d by dx of x square. Okay, sine x square into d by dx of x square. What is d by dx of x square? That is minus sine x square into x square. What is x square? D by dx of x raised to n is n x raised to n minus 1. So d by dx of x square will be 2 into x raised to 2 minus 1, that is 2x. Okay, in the beginning stage we'll write things like this, but when you keep moving forward, you will not be writing all these steps, you will directly come to the answer. So d by dx of x square will be 2x. So if you rearrange and write it properly, it will be minus 2x sine x square. Understood? So this is what is called chain rule. Once you start deriving a function, you will keep on checking if there are more functions coming. Let's say we've said, I just told you that d by dx of cos x equal to sin x. Okay, I told you that. So this, I have found the derivative of cos x. Now I have to find the derivative of the next function as well, that is d by dx of x, which is 1. That is the reason why we usually don't write sin x into dx by dx. So d by dx of sin x will directly give you the answer as, d by dx of cos x will directly give you the answer as minus sin x. That's finished. That's over. See, I found out the derivative of cos x as sin x. Then I apply the chain rule again. I find the derivative of x also. That will usually give me 1, so I don't usually write it here. But here, you see, I found d by dx of cos x square as sin x minus sin x square. Then I did not stop. I'm just moving forward and checking again if there are more functions. Yes, there is one more function x square. So d by dx of x square is equal to minus 2x. There may be cases where you can see multiple functions, not just 2. There will be more than 2 functions. So we'll deal with such questions. So we'll do that in exercise 5.2. Till then, please write. Okay, so let's start with question number 1 of exercise 5.2, which says the function is given as sine of x square plus y, x square plus 5, sorry. So let's say f of x is equal to sine of x square plus 5. So d by dx of f of x, that is f dash of x, will be d by dx of sine of x square plus 5. Okay, so what are the things? You see that there is first function, that is sine x. Then within that function there is another function x square plus 5. So what is d by dx of sine x? D by dx of sine x we already know. D by dx of sine x is cos x, right? That's correct, no? So d by dx of sine x square plus 5, that will be cos x square plus 5. But is it finished? No, you have to set up the chain. The next will be d by dx of x square plus 5. Okay, so what will be x square plus 5? You get, this is cos x square plus 5, just like that. Now d by dx of x square is 2x plus d by dx of 5, d by dx of a constant, d by dx of a constant is 0. D by dx of x square is 2x. How did you get it? D by dx of x raised to n is n into x raised to n minus 1. That is 2 into x raised to 2 minus 1. So that will be 2x plus 0. Okay, so that will be, this is simply 2x. Your answer is 2x cos x square plus 5. Understood? This is the first function. You found out the derivative of the first function. Okay, then you did not stop there. You kept on checking if there are more functions. Yes, you found out a second function inside sin x. Okay, you're finding the derivative of that one also. Now there are no more functions left. If you can see, it is 2x. If you find d by dx of x again, the answer will be 1. So we don't usually write that. Okay, so here is the answer for the first question. Now let's apply this to the second one. Given f of x is equal to cos of sin x. Okay, so what is d by dx of cos x? It is starting with c. So f dash of x will be d by dx of cos of sin x Okay, you have to understand this is cos of sin x, not like cos x into sin x. That's a different story. Here it is cos x or cos of sin x. That's a function within another function. So what is d by dx of cos x? It is minus sin x. Here in place of x you have sin x, so that will be sine of sin x. Okay, is the function over? Keep on checking if there are more functions. Yes, for the function cos of sin x, I found out the answer is minus sine of sin x. Now you have to find the derivative of sin x also, no? You have to find the derivative of sin x also. So that will be minus sine of sin x into d by dx of sin x is cos x. As simple as that. Okay? Easy? So please note it down. Let's go to next question. Okay, so here is question number 3. It is given f of x equal to sine of ax plus b. Very similar to question number 1. So when you find the derivative of this one, you get d by dx of sine of ax plus b. Okay? We know how many functions? There is a sine function, and inside that there is ax plus b. So you have to apply chain rule. So d by dx of sine x is cos x. Instead of x, you have ax plus b. Okay, and we don't stop there. We keep on applying derivative to the function inside. So you get ax plus b also. D by dx of ax plus b. So that is cos ax plus b. Okay, because the derivative part is over, nothing else to do. Into d by dx of ax. There is a constant and then there is x. So the answer will be a. Directly you can write the answer as a. Or if you would like to apply rules, then you will say a comes outside. You are applying d by dx of x plus d by dx of b. Okay, this is just like learning for addition. In the initial stages, we'll write all these steps, but later we will be directly writing d by dx of ax as a itself, because we know what the ending would be. So cos of ax plus b, this is 1 and this is 0. Okay, this is a d by dx of a constant into a. So your answer is a cos ax plus b. Here, these questions will not be asked for your exam. This is only for you to understand how derivatives work. Okay, you can directly look at this and tell the answer is a cos ax plus b. But right now, we will be applying all the steps and getting the answer. Similarly, here is question number 4. So given f of x equal to sec of tan root x. Okay, how many functions are there? There is sec. Okay, it's first function. Inside sec there is tan, and inside tan there is a root function. Okay, so here is that case where there is more than two functions inside. So let's find out. F dash x will be d by dx of sec of tan root x. Okay, what is d by dx of sec x? We already know. D by dx of sec x equal to sec x tan x. Okay, so can I write d by dx of tan root x equal to sec tan root x? That is, instead of x we have tan root x here. So sec x tan x, tan of tan root x. Okay, that is the sec part. That is the sec part. You've just finished sec x tan x. Okay, is it over? No, it's not over. Now we have to apply d by dx into d by dx of tan root x. Tan root x. What is d by dx of tan x? D by dx of tan x is sec square x. Do you understand the importance of learning the formula? Yeah. So that will be sec of tan root x. Sec of tan root x. Tan of tan root x into d by dx of tan root x. What will it be? Sec square x. Instead of x, we have root x. So sec square root x. It's not finished yet. It's not finished yet. You have to apply d by dx of x sec root x. Okay. So what is this root x? Root x is x raised to 1 by 2. Right now, root x is x raised to 1 by 2. So according to the formula, that is n into x raised to n minus 1, you get 1 by 2 into x raised to 1 by 2 minus 1, or that will be 1 by 2 x raised to minus 1 by 2, or 1 by 2 root x. Okay, that is the derivative of root x that we'll apply here. So you get sec of tan root x, we're writing everything again, tan of tan root x, sec square root x into 1 by 2 root x. Okay, don't get too enthusiastic and cut this root x and root x. That's not possible. This is inside a function. Okay, there are some people so intelligent about, they'll start thinking all those things. This is sec square root x into 2 root x. Okay, I hope you are getting the idea of applying chain rule. We are looking at how many functions are there inside the question. There is first function that is sec, there is a second function that is tan, then is a third function that is root x. So I just applied chain rule to each function and I got the answer. That's the answer for question number 4. Alright, so please take a note. Let's go to the next one. Okay, so here is question number 5 of your textbook, which says f of x equal to sine of ax plus b divided by cos of cx plus d. Let's see what we can do. This is numerator and this is denominator. I told you whenever you have functions in this form, that is f of x by g of x, then f dash of x is equal to, is of the form numerator by denominator, that will be d n dash minus n d dash by denominator square. That's what I told you before. Okay, so let's apply this here. F dash of x will be, observe carefully, f dash of x will be denominator, that is cos of cx plus d. Okay, we are going very slowly, okay, so that you understand things very carefully. Denominator into dy dx of numerator, that is sine ax plus b. Okay, minus numerator, that is sine of ax plus b into dy dx of denominator, that is cos cx plus d, the whole divided by, I'm not very sure if I can draw a line so straight enough to accommodate, yeah, I think that's fine, whole divided by denominator square, that is cos of cx plus d the whole square. The whole square, or for ease of writing, you can simply write it as cos square cx plus d. Okay, there is no derivative or anything, it's just simply square. Okay, that's done. Now let's find out. Oh, we have to write everything again. So that will be cos cx plus d, cos of cx plus d into, okay, what is d by dx of sin x? That is cos x, cos of ax plus b. Okay, is the function finished? No, there is ax plus b inside, so d by dx of ax plus b will be a. Like before, I'm not writing d by dx of ax plus b again, I'm simply giving you the answer, okay, as a. This will be multiplied with a. Like before, d by dx of ax plus b will be d by dx of ax plus d by dx of b will be 0. Your answer will be a, no? So that I've written it directly here, otherwise your answer will be very long. So we'll stop that practice from here onwards. Minus sine of ax plus b, sine of ax plus b into d by dx of cos of cx plus d. Now tell me, what is d by dx of cos x? I know d by dx of cos x starting with c, so minus sine x, okay, into minus sine cx plus d, into, the function is not finished. The function is not finished with cos. You have to apply d by dx to the inside also, chain rule. So d by dx of cx plus d will be c. Okay, this is multiplied by minus sine x. Okay, don't write it as sine ax plus b minus sine cx plus d. That's different. This is multiplication of minus sign, and the whole divided by, okay, I did the line correctly now, yeah, whole divided by cos square cx plus d. Haha, so simple. Now this is a negative into negative, this becomes positive, and when you rearrange things, you get a cos. Now that's how we usually write it for the sake of beauty. This a comes first, so the constant into cos of cx plus d into cos ax plus b it was minus, this will become plus c into sine ax plus b into sine cx plus d whole divided by cos square cx plus d. Okay, now this will be your answer. Sir, such a big answer for a small question. You're in 12th standard, dear. Yes, this is the answer for this question. Your answer is finished here, but if you want to match your answers with your textbook answers, then you can simplify this further. You know what I'll do? I'll just split this fraction like cos square cx plus d here, cx plus d here, plus cos square cx plus d here. From here, one of the cos will get cancelled with this one. This is gone. So finally you have a cos ax plus b divided by cos cx plus d. That is 1 by cos cx plus d will be, what is 1 by cos? Sec of cx plus d into cos of ax plus b. Plus here also, here sine of cx plus d by cos of cx plus d. So one of the cos gets cancelled with this one and it becomes tan. So that will be c into sine ax plus b. Sine by cos is tan cx plus d, okay, into 1 by cos into sec of cx plus d. Okay, so in this way you can match your answers with the textbook answers. You can, simplify, otherwise your answer is finished here. Okay, if you would like, you can transform your answer into this form. Okay, so let's go to question number 6. Hey, so this is question number 6. Let's pay attention to how many functions there are. Let's consider this as first function and this as the second function. Okay, there is a cos and there is sine. There is x cube inside cos and there is x raised to 5 inside sine. But pay attention, this is sine x raised to 5 whole square. Okay, so that itself can be considered as a function. Okay, that's your question. Now we'll start solving. F of x is equal to cos x cube sine x raised to 5 the whole square. Okay, so this is first function, this is second function. Alright, so now can we apply the product rule? Yes, we can. F dash of x equal to d by dx of cos x cube. So I think we don't need to write that. I'll just directly apply the product rule. That is first into derivative of second. That is cos x cube into d by dx of sine x raised to 5 whole square plus second into derivative of first. That is sine x raised to 5 whole square into d by dx of cos x cube. Pay very close attention to what I'm doing. So look at this. There is a square function in the first place. Okay, so let's do that first. See, let's consider this as d by dx of, let's say this sine x raised to 5 is t, then that will be t square. Your answer will be 2 times t, no? If this whole thing sine x raised to 5 is taken as t, sine square, then t square will be 2t. So this will be cos x cube into 2 sine x raised to 5. That comes first. Okay, apply chain rule. So the square function is over. Next there's a function inside, that is d by dx of sine x raised to 5. So do I need to write d by dx? No, I need not write. No, I'll just simply write, okay, d by dx of sine x raised to 5 is cos x raised to 5. Now is it still finished? No, then you have x raised to 5 pending again. So d by dx of x raised to 5 is 5x raised to 4, n into x raised to n minus 1. Okay, I'm not writing d by dx in between. It will simply make the problem very congested. So I'm just directly writing the answer. Okay, so this part is finished. Now there's nothing to do, so you'll write it as it is. That is sine square x raised to 5 into d by dx of cos. What is d by dx of cos? It is minus sine x cube into, is it finished? No, it's not finished. D by dx of x cube is pending. So d by dx of x cube is 3x square. Again, n into x raised to n minus 1, right? D by dx of x raised to n is this answer. Okay. So let's rearrange and write everything properly. Is there anything you can take as common? No, not really. So I think sine x raised to 5 can be taken as common. So is there any use taking it out? No, actually. So this 2 and 5 will become 10x raised to 4, then cos x cube sine x raised to 5 into, okay, 2 I've taken, 5 I've taken, that is 10, then x raised to 4 is here, then cos x cube and cos x raised to 5, okay, cos x raised to 5, and then you have sine x raised to 5, plus, here what do we have? Okay, this minus comes here, so this becomes minus 3x square, 3x square is gone, sine x cube sine square x raised to 5. Anything you can take as common? No, right? No, there's nothing you can take as common. X raised to 5, sine x raised to 5, you can take as common if you want, but that doesn't make any sense, so your answer is finished here. Okay, so that is question number 6. Let's go to question number 7 now. Okay, question number 7 and 8, you can do it on your own. Now we'll go with question number 9. Okay, it says prove that the function f given by f of x equal to mod x minus 1, where x element of R is not differentiable at x is equal to 1. Okay, this is what we have to prove. So what does it mean by saying that a function is differentiable? We've learned that a function is said to be differentiable at point A if limit x tends to a, f of x minus f of a divided by x minus a exists and is finite. So that's what we've learned. So we'll apply this similar principle here. Let's define the function carefully. It says f of x equal to mod of x minus 1 and x element of R, okay. But we cannot operate, we cannot apply limits when this is in the modulus form, okay. So we have to break this function. So this modulus has a job only when this x minus 1 becomes negative. Okay, what is the function of a modulus? If it is mod 3, you will put it as 3. If it is negative of 3, then modulus of negative 3 will be 3. Okay, so this is where it starts working. Whenever there is a number inside, the modulus function starts to function. Otherwise, if you put 3, you will get 3. If you get 4, you get 4. Any positive number you put here, you get positive number here. But if you put a negative number, then the modulus starts working and it starts to attack this negative sign and it will make it positive. That's only when the modulus function has some job to do. Okay, so let's say, when does this work? That is like, it needs to be, the modulus function starts working only when x minus 1 is less than 0, that is x less than 1. Okay, it only has a function whenever x is less than 1. Alright, so let's say x minus 1 less than 0 means x less than 1. So f of x can be written as x minus 1 itself whenever x is greater than or equal to 0, greater than or equal to 1. Whenever x is greater than or equal to 1, there is nothing you have to get worried about. Okay, greater than 1 means this is always a positive number, so it will stay like this. And it becomes minus of x minus 1 whenever x is less than 1. Okay, it starts to perform, this modulus function starts to act whenever x is less than 1. See, I told you, whenever this whole quantity becomes negative, that's the place where the modulus starts to function. So in order to make it positive, I have to multiply it with a negative number. So this is my function defined at x is equal to 1, x greater than 1 and x less than 1. Okay, now let's apply limits. The left hand derivative and right hand derivative should be there. Okay, so let's apply left hand derivative. That is, limit x tends to 1 minus f of x minus f of a, that is f of 1, divided by x minus 1. Okay, so this is 1 minus, so this becomes x minus something, some quantity, sorry, not x minus, 1 minus some quantity h minus f of 1 whole divided by 1 minus h minus 1. Okay, x, x is tending to 1 minus, that is towards the left side of 1. Let's say here is a number line, this is 1, x lies somewhere here, okay, some quantity here, that's where x lies now. So I am writing it as 1 minus h, and that h is so small that it tends to 0. Okay, limit h tends to 0, f of 1 minus h minus f of 1 by 1 minus h minus 1. Okay, so when it is less than 1, what is the function you have? You have minus of x minus 1, that is in place of h, x, what do you have? 1 minus h. 1 minus h minus 1 minus f of 1. What is f of 1? That is 0. 1 minus 1, right? No, f of 1 is x minus 1, that is 1 minus 1, 0. Okay, whole divided by 1 minus h minus 1. 1 and 1 cancels, you had minus h. So here 1 cancels, and you have positive h divided by negative h. Your answer is minus 1. That is your left hand derivative. Now let's go to the right hand derivative. That is, what is right hand derivative? Limit x tends to 1 plus f of x minus f of 1 divided by x minus 1. So 1 plus means it is somewhere to the right of 1 at a very small quantity h. So this becomes f of 1 plus h. Okay, some value greater than 1, I don't know, and minus f of 1 divided by, instead of x I have 1 plus h minus 1. Here limit h tends to 0. What does that mean? H is such a small value, but it is greater than 1. So whenever the function is greater than 1, this is your function, no? Whenever x is greater than 1, this is your function. That is x minus 1, that is 1 minus h minus 1 minus f of 1 is also, f of 1 is 0 divided by, what else do we have? H. Okay, so here it is limit h tends to 0. Okay, don't apply limit yet. So here you have limit h tends to 0, h by h is 1, so your answer is 1. Okay, so for the left hand derivative you have minus 1, right hand derivative you have plus 1. So that is two different slopes. So left hand derivative not equal to right hand derivative. So can I say the function is not differentiable at x is equal to 1? Understood? This is limit x tends to 1 minus, limit x tends to 1 plus, left hand derivative, right hand derivative. You get two different answers, so the slope is also different. So you can say the function is not differentiable at this point. Okay, usually a modulus function is a continuous function, but it is not a differentiable function. You just proved that here. Okay, so please note it down. Let's go to question number 10. Okay, so here is the 10th question, which tells you to prove that the greatest integer function defined by f of x is equal to box x, where x lies between 0 to 3, is not differentiable at x is equal to 1 and x is equal to 2. Okay, so we already said that for a function to be differentiable, this is the condition that limit x tends to a, f of x minus f of a whole divided by x minus a exists and it is finite. Okay, so we'll apply this condition here. So here we have the greatest integer function. From your 11th standard you have already learned that if this is a function, if a number is given as 1, greatest integer function stands for greatest integer less than or equal to the given number. So this is 1 and I'm taking 1.1. So the greatest integer less than or equal to 1.1 is 1, right? That's definitely not equal to 1.1. So the greatest integer that is less than 1.1 is 1. If I take 1.2 also, it jumps back to 1 because that is the greatest integer which is less than 1.2. But what if I go to the left side? What if I take 0.9? I have to choose that integer which is less than 0.9. So your answer will be 0. This will jump from 0.9 to 0. whatever integer is, whatever number is given, real number is given, it will jump back to that integer which is less than that given number. Okay, so here it says you have to check differentiability at x is equal to 1. Okay, my function is greatest integer function box x. Okay, so let's say you have to prove differentiable at x is equal to 1. Okay, so I am going to prove this differentiability at x is equal to 1. Okay, so this is 1. So to the left of 1, let this be the point and this difference be h. Okay, so this point is 1 minus h, and to the right I am going to take 1 plus h. This point is 1 plus h, and there's a small difference h which is very close to 0. So let's apply limit. So limit x tends to, at x is equal to 1. Okay, at x is equal to 1, I'm going to check differentiability. So left hand derivative will be limit x tends to 1 minus f of x minus f of 1 divided by x minus 1. Okay, so 1 minus, that is less than 1. So here it will be limit h tends to 0. H is a very small number. X is replaced by 1 minus h by f of 1 by x is replaced by again 1 minus h minus 1. Okay, so what is 1 minus h? A number less than 1. So it will obviously, so this is the point. I told you the number is now less than 1. So the greatest integer will be 0, no? Okay, let this point be 0.99 whatever, but the greatest integer that is less than this number is 0. So it will jump back to 0. So 0 minus, what is f of 1? 1 itself. Okay, if you're choosing 1, the greatest integer less than or equal to 1 is 1 itself. Then 1 minus this, so limit h tends to 0 minus h, or you get limit h tends to 0, 1 by h, this will become not defined, because h, if it becomes 0, it is not defined. Now the right hand derivative is limit x tends to 2, sorry, x tends to 1 plus f of x minus f of 1 divided by x minus 1. 1 plus, now this point is gone. I'm taking a new point that is towards the right side of 1. Let it be 1.1 plus h, or let's take it as 1.0001, whatever be. If you apply the greatest integer function here, it will jump back to 1 itself. Okay, we'll come to see. Okay, so limit h tends to 0. H is a very small quantity, that is it tends to 0. It's such a small quantity. X is now replaced by x plus h minus f of 1, not x plus h, sorry, 1 plus h minus f of 1. Again, x is replaced by 1 plus h minus 1. Okay, so this 1 and 1 cancels, and you have f of 1 plus h will be 1 itself. F of 1 is 1 itself, that is 0, numerator is 0, divided by h, that is limit h tends to 0, 0 by h. This is not 0 by 0, this is 0 by h. H is very close to 0, so you don't consider it as not defined. This, the answer will be 0. Okay, don't say that says it is 0 by 0, this is again not defined. No, this is 1 defined by a very small value, so that's why I said it is not defined. But here it is not 0, it is 0 multiplied by some number that is infinity. So again your answer will be 0. H is not 0, it tends to 0, so don't write it as not defined. So here the left hand derivative is not equal to right hand derivative, right? So this function is not differentiable at x is equal to 1. Okay, the next point is x is equal to 2. So what happens? Instead of 1, you'll put 2 here, and then this will be 2 minus and 2 plus. Apply in place of x, this will be 2 plus h. In place of x, it will be 2 minus h. So please proceed with the second part of the question, that is checking differentiability at x is equal to 2 also. And with that, we have solved all questions from exercise 5.2. Question number 7 and 8. I think that's for you to do on your own. Alright, so with this, we'll move on to the next topic. Okay, see you in the next video. Bye-bye.